9.3 Hyperbolas. What we should learn: write equation of hyperbolas in standard form, find asymptotes of and graph hyperbolas, use properties of hyperbolas in real life problems, and we're going to learn how to classify conics from general equations. So hyperbola is similar to an ellipse. They're going to have very similar formulas. You find foci the same way. It's still going to be a squared plus b squared equals c squared, some version of that. The difference is with an ellipse, you're adding the x and the y squared, and a hyperbola, you're going to be subtracting them. And when you get a hyperbola, it looks like this. Right? It's like these upside down parabolas I see. Or we can do sideways if it's going to be y squared. Here's the standard form, very much like an ellipse: x minus h squared over a squared minus y minus k squared over b squared. Notice how in one of them the x squared is positive, in this case the y squared positive. When it's x squared positive, the transverse axis is horizontal. That just means it's going to look like this. The major axis is going to be horizontal. So if we put these together, it looks like an x. When it's y squared positive, it's going to be vertical transverse axis. It kind of looks like two upside down y's. Y squared up and down, or x squared horizontal. And then that's just your center. It's all that same. Now the way you find the foci is different. Similar idea, but the foci is a different formula. It's c squared equals a squared plus b squared. It's not the subtraction. Notice how the hyperbola is a minus here, so it's a positive down here. And when it's an ellipse, it's opposite. It's a plus here, so it's a minus over here. So that's how you find the foci. It's only a little difference. Other than that, it's kind of the same thing. Here's what they look like. You can see our center is hk there, much like before. You'll add a to get to the vertices, and then you'll add the c to get to the foci, which is always on the major axes. Example 1. Find the standard form of an equation of a hyperbola with foci -1, 2, 5, 2, and the vertices of 0, 2, 4. Okay, for me, it's always best to graph it, because you want to have some idea what it looks like, and that leads to everything. The foci are at -1, 2, and 5, 2. 1, 2, 3, 4, 5, 2. Already I know it's going to be an x squared one. The x squared is going to be positive, so it's going to be x minus h squared over a squared minus y minus k squared over b squared equals 1. Just because the foci is horizontal, it means that it's going to be a horizontal one. The vertices are at 0, 2, 4, 2. 0, 2, 4, 2. I guess a couple of things. First, my center is always halfway between these guys. It's always halfway between the vertices and halfway between the foci. Like if I know where halfway is, add them up and divide by 2 any way you want to do it. Halfway between these two is going to be, that's 0 and that's 4, 2. So this would be my center with that 2, 2. That's going to be a 2 and that's going to be a 2. Remember, foci in a hyperbola, the distance from here to the foci is c. So c here is, we're going from 2, 2 all the way down to -1, 2. So we went 3. I went 3 spots that way, 1, 2, 3. And my a, because this is the major foci length, is the distance between here. It looks like we only went 2, 1, 2. So I have almost everything. I just need to find b squared. Now the way you find b squared is we have our foci formula. We have a squared plus b squared equals c squared. We have a and c. Let's plug it in. So this is going to be 2 squared plus b squared equals 3 squared. I get 4 plus b squared equals 9. B squared is going to equal 5. We subtract 4 from both sides, square root it. B is equal to the square root of 5. So now we have everything we need to plug it in. B is square root of 5. A is 2. So let's simplify that. We have x minus 2 squared over 4 minus y minus 2 squared over 5. When you square it, the radical cancels out, equals 1. And that's my equation. Asymptotes of a hyperbola. So this is the form of an asymptote of a hyperbola. Basically what we do is we're make a box using our vertices. From here to here is our A, and then from here to here is our B. Then we make a box out of that, and then through the edges of the box, you have your asymptotes. That's the way it works. Let's do an example. Let's sketch this hyperbola. Since we know it's a hyperbola, you know it's not even, there's a minus there. We're gonna have to get it equal 1. Let's divide by 16, and we get x squared over 4 minus y squared over 16 equals 1. Next, we gotta find our center. Center is 0, 0. We have a is 2, square root of that. This is a squared. This is b squared. B is 4. What we're going to do is we're going to graph it. Our center is 0, 0. Makes life easy. A is 2. In this case, it's the x. We're going to go 2 on the x. That'll be my vertice there, my vertice there. Our b is going to be 4 and go up 4 on 1, 2, 3, 4. And 1, 2, 3, 4. Then we'll make a box out of that. For our asymptotes, we're going to go between the center and the edges of the box. So kind of this. And there you are, asymptote, but you can't cross them. Same thing on this side. Now remember, it is x squared. I know the y squared is bigger, but it is x squared is positive. They're going to go on this curve. But just to make it perfect, let's find the foci. I haven't found the foci yet. Foci. C squared equals a squared plus b squared. So for us, it is going to be 4 plus 16. C squared equals 20, square root of 20. So that's about 4.4-ish. We're going to go about 4.4 this direction. And about 4.4 this direction. our parabola should open like this, sideways. And then if you want to hug the asymptotes like that. And that's the sketch of our parabola. We have asymptotes, we have our vertices, we have our center, and we have our focus. Sometimes it might ask you for the equation of the asymptotes, and that's actually not as bad as it looks. There's a formula for it. I showed you earlier. It is y equals k plus or minus b over a x minus h. And that's the same formula if it's horizontal or vertical, does not matter. Because these asymptotes would also work if our graph was a vertical graph. So in this case, our h and k, our center is 0, 0. That's 0, and this is 0. Our b was 4, and our a was 2. So we're going to get y equals plus and minus 2. 4 divided by 2 is 2x. So y equals plus and minus 2x. Those are our equations of the vertices right here. Okay, on to the next one. Sketch a hyperbola given this and find the equation of the asymptotes. But again, it's a parabola. We're going to do the same thing we do with all of these. We're going to rearrange. So you want the x plus the y, in this case minus the y. Well, depends, plus and minus the y, equals c. And then 2, we're going to complete the square. And then 3, we're going to simplify factors. So let's rearrange first. So in this case, x squared is positive and y squared is negative. I'm going to put the x squared in front. If y squared is positive and x was negative, I would have switched it. Minus 3y equals negative 16. Whoops, 3y squared. I only have an x that I compute the square on. But let's compute the square on the x. Y, I don't have to do anything for now. Remember, we always have to factor out the number in front. So it's x squared plus 2x. Then we're going to compute the square. We'll get the middle term divided by 2 and square it. We get 1, so plus 1. But we do have to add on this side 1 times 4. So it's 4 we added that side. We're going to leave the 3y squared alone, and I get negative 12. Okay. Next, we have to factor this. It always factors perfectly. The thing before is squared. So x plus 1 squared minus 3y squared equals negative 12. Remember, we got to make this equal 1. We're going to divide by negative 12. That's actually going to flip what's positive and what's negative. Right? Reduce if you can. So that's going to be 1 and 4. That's going to be 1 and 3. This actually becomes a positive, because double negative. We're going to get y squared in front over 4 minus, this became a negative, x plus 1 squared over 3 equals 1. But now we have everything we need. If I wanted a center, it is negative 1, 0. You do got to watch out. Remember, the y is in front here, but still h and k. Negative 1, 0 is my center. My a is, remember, this is a squared and b squared. My a is square root of 4, which is 2, and b is square root of 3, which is just square root of 3, 1.7-ish. Right, a in this case is the y value. We're going to go up and down 2. 1, 2 right there, and then 1, 2 right there. Then we got to go square root of 3 left and right. That's like 1.7 over here, over there. It's a little funky. If I want the foci, c squared equals a squared plus b squared. C squared equals 4 plus 3. C equals square root of 7. I get like 3 point something. Now again, this is the y value. We're doing y squared and go up and down. Square root of 7, 2.7. It'll be up there and down there. Our asymptotes, they always go through the edges like that. They want the equation of the asymptote. In this case, it's going to be y equals k plus or minus. I think I might have said it wrong before. It's the slope x minus k. But the slope is always y over x. The slope here should always be the y value over the x value. In this case, our y value is 4 over a squared over b squared, a over b. So that's the thing about the slope. It should always be the y over the x. If it's x squared minus y squared, and you have a squared b squared, then in that case it would be b over a. But if it's y squared minus x squared, a squared b squared, in that case it would be a over b. Slope should always be y over x, whatever y over x is. So in this case, since we're doing a over b because y is positive, we're going to have 2 over our b, which is square root of 3. H and k is our center, which is negative 1, 0. Remember, this is h and k always. X always gets the h. K always gets the y. The y equals plus or minus 2 over square root of 3, x plus 1. That's the equation of our asymptotes. And the only thing I have left is actually graph the hyperbola. Now remember, y squared in this case, so it's going to be up and down. So it's going to be this. You want to hug the asymptotes, don't overcross them. And the same idea here. That's the graph of hyperbola. We have a graph, we have the equation of the asymptotes, we have the foci, we have the vertices, and we have the center. We have everything. Okay, let's do the next one. The next one, we're going to use the asymptotes to help find the standard equation of the hyperbola. So first, anytime they give us vertices or anything, I would plot it. Now, they already have it plotted for us. I would have done it myself because it always helps figure out the equation. So over here, vertices at 3, negative 5, and 3, 1. We already know the basic equation. This is a y squared. the positive y and a negative x. We're going to have y minus k squared over a squared minus x minus h squared over b squared equals 1. And on top of that, I already know what the center is. It's always halfway between these two. You do a little midpoint, the x has to be 3. And if you want to find the midpoint between 1 and negative 5, the midpoint of anything is just add them up and divide by 2. So you get negative 4 divided by 2 is negative 2. So that's my midpoint. That's my h and k. K goes here, h goes there. And then my a, well, that's how far from your vertices is your center. A is this guy, and that's 3. This is 3 squared. All we have left to figure out is what b squared is. Normally we use the foci. We don't have it this time. So we're going to have to use the equation. Remember, the equation of the asymptotes is y equals k plus or minus, it depends, you want y over x. In this case, y is my a, let them be a over b, x minus h. And we know a couple of things. We know h is 3, we know k is negative 2, we know a is 3. We just got to figure out what b is based on this guy here. So let's simplify both of these a little bit. Y equals negative 2 plus or minus 3 over b, x minus 3. Now I want to make this guy, one of these, doesn't matter which one of these guys looks like this guy. Let's work with this one. Y equals 2x minus 8. Now what happens here, what if I factor out a 2 to make it look like this? I'm going to get x minus 4. That's not going to work. Also, I need a negative 2 out there. It's a little tricky. We're going to split this up. I'm going to make it 2x minus 6 minus 2. That equals negative 8. Why did I put a minus 2? Why did I take out the negative 2 from there? Because that would match this guy. So that's why I used negative 2. I was like, okay, well, if I take a negative 2, what's left over? Negative 6 is left over. And now, we could factor this. Factor out 2, I get x minus 3 minus 2. If you look at it, it does match this guy pretty much. If I rewrote this like this, negative 2 plus 2x minus 3. Doesn't that guy match this guy? That means that this matches this. We have 3 over b equals 2. Cross multiply, since it is an equal sign. 3 equals 2b, divide by 2. And you get b equals 3 over 2. So we have that. Go back up here, plug it into our formula. This is 3 over 2 squared. And we get our equation. Y plus 2 squared over 9 minus x minus 3 squared over 9 over 4 equals 1. And that's our equation. That's pretty much it for hyperbolas. Now let's look at all conic sections in general. General equation of conic sections. When I give you one of these, a long equation, I want you to be able to look at it and go, okay, I know what that is. I know if that's a circle, a parabola, ellipse, or hyperbola. With the circle, they're going to be balanced. So ax squared and y squared, it's all about the x squared and the y squared. They're going to be balanced. They should be equal. A and c would be the same. With a parabola, you only have one square. That's easy. With an ellipse, a and c should be both positive. And with a hyperbola, a and c, one of them will be negative. That's the general idea. If I look down here and go, okay, look at this first one. I just want to know which one it is. We don't have to solve it. A, clearly a parabola. There's only one x squared. So it's an x squared parabola. It's an x going up. B, let's look at the x squared and the y squared. One of them is negative. That's a hyperbola. C, I have an x squared and a y squared, but they're not the same number. Y squared is a little bigger. That's what makes it an ellipse, because it's uneven. So this is an ellipse. And then D, see how the x squared and the y squared? They're both the same number. So that's going to be equal. That's going to be a circle. So that's how you can tell, if I give you a general conic section, how to classify it. Now, I'll probably ask you to go further and give me the center and give me the vertex and all that stuff. But in general, if I ask you to classify one, that's how you do it. And that's the lesson.